So we're now going to pick back up in our video on the refraction of light at a boundary and then the dispersion of white light. We're going to finish that off with an exam style question. So let's look at the setup we have below. We have that red light shines onto an open fish tank with a glass bottom as shown below. You see that's labelled. So we've got air here, we've got water here, we've got glass here, we've got this is our instant ray, and that's coming in at an angle of 40 degrees to the normal. This green line is the normal. So in an exam you'd be labelled with this stuff. They probably wouldn't label the right way, but we've labelled that as well just to help. You'd be labelled that this is air, that this is water, this is air, this is water, this is glass. You'd be labelled those things as well. So they started off by saying, well, the refractive index for red light in water is about 1.33, and it's red light. That's specific refractive index for red light. Remember we were discussing how in this bit here on the dispersion of white light, we were discussing how different wavelengths of light refract by different amounts. Well, here they've given it the refractive index for red light. It's about 1.33. So again, as they said, if the incoming rays incident at an angle of 40 degrees to the normal sketch there, normal to the surface, that is, they want us to calculate the angle of refraction and sketch the refracted ray. Well, what equation we're going to do here? They want the angle of refraction. So here we've got our bog standard, air/vacuum, n's approximately equal to 1 here. And we've got the refractive index of red light in water, n is 1.33. So we can work out just what it is using our standard Snell's law. N equals sine theta I over sine theta r. So then we're going to rearrange to find sine theta r is just equal to sine theta I over n. But we're given that I is 40, so that's going to be sine of 40, and n is about 1.33. So that theta r is just going to be the inverse sine of that, which is sine 40 over 1.33. So it's the inverse sine of, well, actually, let's work out what that is in brackets. Now, if you had normally when you've got a calculator, you would just work this out. You'd calculate this number here, and then you'd all in one calculation take the inverse sine of it and then get you the answer, just so that we can see the kind of numbers propping up. We'll work out what that is. So sine of 40 divided by 1.33. So that bit here is just 0.4832 ... And then if we take the inverse sine of that.
Hey guys, to continue watching this video and unlock hundreds of other super concise and exam board specific A-level physics videos, just click the Snap Revise smiley face. Join me today, and together let's make A-level physics a walk in the park.